Hello, today we shall come to know how to do the organic conversion. That is the important question for the board examination. And you can see that the first row, which is written with black color, it shows the conversion with same number of carbon. It means the number of carbon in the reactant and the number of carbon in the product will be same. And we proceed in the cyclic process. Like here, this haloalkane on reaction with aqueous potassium hydroxide convert into alcohol since it is the primary haloalkane, that's why we are getting the primary alcohol. This primary alcohol on heating with copper at 573 Kelvin temperature convert into aldehyde. This aldehyde you can oxidize by using any of the oxidizing agent into the carboxylic acid. You can see that after carboxylic acid, first reagent is the ammonia, and with this reagent it will convert in the ammonium carboxylate, and then that ammonium carboxylate on heating convert into amide. The number of carbon is still same. With this amide we can do the dehydration with P2O5. On heating it convert in the alkane nitrile. With reduction with lithium aluminum hydride it will convert in the primary amine, and you can see that we have taken bromine and KOH alcoholic. It is also primary amine, but here the number of carbon is decreased. It means one carbon will be less. The second row represents the step up conversion, and step up conversion we can do with two processes. First you can see that haloalkane react with KCl, it will convert in the alkane nitrile. Then with alkane nitrile we can do the reduction by using lithium aluminum hydride, and we are getting the primary amine. This primary amine we can get also from the alcohol by the ammonolysis reaction. This NH2 group is replaced by NaNO2 and HCl, and then OH is obtained. Either we can have here direct nitrous acid, it will also give the alcohol. This alcohol on reaction with PCl5 it will convert into chloroalkane. My dear, whenever one carbon has to increase, first of all we have to convert the substance into the haloalkane, then only we can add the carbon. It means, suppose it is methyl alcohol and from there we have to convert it to the ethyl alcohol. So first of all methyl alcohol has to be converted into the chloroalkane or bromoalkane or bromomethane, and then that bromomethane will treat it with KCl to give the ethane nitride. This is the process. The second is, we have taken the haloalkane with magnesium in presence of dry ether, it will form the Grignard reagent. With this Grignard reagent we can do a lot of conversion. I have taken only one, that with carbon dioxide and water it convert in the carboxylic acid. So this carboxylic acid on reaction with PCl5, this PCl5 replace OH group wherever it is present, convert into the acid halide. From this acid halide we have taken the sodium ethoxide, will get the ester. Whether it is the ester or it is the acid halide, if these are treated with ammonia, it will convert in the amide. Step down conversion means one carbon or more than one carbon has to decrease. Whether it is the haloalkane or it is the alcohol, for haloalkane we can take the alcoholic potassium hydroxide, and for alcohol we can take the concentrated H2SO4. On heating at high temperature it convert in the alkene, and then with ozone it will form the ozonide, which on heating with zinc dust or zinc with water convert in the carbonyl carbon, which might be aldehyde, it might be ketone. And the second thing is, we can convert the haloalkane into alcohol into the carboxylic acid into the sodium carboxylate, and sodium carboxylate on decarboxylation reaction convert in the alkane, and from again alkane into the haloalkane by reaction with halogen in presence of ultraviolet radiation. So this is the chart by which we can do the maximum conversion. Here I have taken one or two examples. Even last year in the board also this question was being asked. Methyl bromide has to be converted to acetone. For that what we have to do? We can do simplest step. We can involve. It has to be converted into the Grignard reagent. Grignard reagent is converted into the carboxylic acid. Then calcium hydroxide and dry distillation, this acetic acid will convert in the acetone. Then methyl chloride to acetic acid, the same conversion up to here. Ethyl alcohol to propanol. Even I had asked you earlier that directly we can't increase the number of carbon. That's why first of all I have converted this alcohol into the chloroalkane. Then you can see this KCN I have taken here, one carbon increase. After reduction, primary amine, and then with NaNO2 and HCl, we are getting the propane 1-ol. The fourth one is propane 1-ol into the propane 2-ol. What we have to do here, propane 1-ol, we can do the dehydration, we can get the alkene. Then, by addition of halogen acid to the Markovnikov rule, we can get the secondary haloalkane, which are reaction with aqueous KOH converted into propane 2-ol. Butane 2-ol to acetaldehyde. You can see that 4 carbons are present in the reactant and 2 carbons are present in the product. Means this decarboxylation is not applicable. We have to use this one. That's why I have converted this alcohol into the alkene, that is but2ene, then ozonolysis, and then this ozonide is heated with zinc and water to give 2 molecule of acetaldehyde. So this is a short review for the conversion. Thank you and good luck.